Hello, today we're going to be looking at section 1.4 and we'll be using a graphing device called Desmos, which I have pulled up right here. As you follow along, you may also want to have either on another device or at least in a separate screen this desmos.com, and you'll have to click on the Launch Calculator app, I believe. So desmos.com, alternative to a handheld graphing calculator, it's free. And it's actually kind of amazing. It does a lot of things that your handheld calculator, it does a lot of things more easily, I guess I should say, than your handheld calculator. So you might want to pull that up before you start listening to the rest of the notes. And speaking of the rest of the notes, here we go. In section 1.4, we're now going to try and put all the things that we've been talking about together. We've talked about looking at data and functions numerically, graphically, and analytically. And I'm going to now take one problem and try and look at that same problem all three ways. We'll also look at it by hand and with technology so that you can start to compare and contrast the ease or difficulty that both of those that happens with both of those. All right, so in my first example, you are renovating your kitchen and you're going to need both a plumber and an electrician to do some work on it. This is how they charge. The plumber, $25 service charge, so that's just for coming to your house. And then they also charge $80 per hour. They'll work no more than 10 hours a day. The electrician, a $40 service charge for coming out, $65 an hour, maximum of 8 hours per day. We're going to try and write functions for the plumber's cost in one day and for the electrician's cost in one day. And we'll start by defining the variables. In both cases, I'm going to let my input or independent variable be H, the hours that they work. P then can be the plumber's cost, and E can be the electrician's cost. All right, I'm now going to work for a while specifically with the plumber. I'm going to go through and we're going to do a number of different things. We're going to look at the plumber's function, both graphically, numerically, and analytically. And then we'll go back and we'll try and do the same thing for the electrician, only we'll use technology for that one, so that you can kind of compare and contrast the by hand method and the technology method. All right. We do need to write the function, and this one I do have to do by hand for both of them. It's one thing technology can't do for me is figure out the functions, right? Or at least not for verbal given information. So I want the cost of the plumber's visit, and I want to use function notation. So the plumber's cost is a function of the hours that he works. And we know that he charges $80 per hour. So I have to take 80 and multiply by the number of hours that he's at my house. And then he also charges a $25 service charge. So I'm going to add $25 to that. Similarly for the electrician, take just a moment and see if you can write down the electrician function for the electrician's cost. Hopefully you came up with something that looks like E of H is equal to 65H plus 40. That's the $65 per hour times the number of hours plus the $40 service charge. All right, I'm going to go ahead and just put both of those analytic function notations right here at the top of the next page, just to make it a little easier to work with. So we said that P of H was 80H plus 25, and E of H was 65H plus 40. All right, the next thing I want to do is make a table of values that illustrates this function. So I'm now going to be looking, instead of analytically, I'm now going to be looking at this function numerically. So my input is H, that goes on the left side, and my output is P, goes on the right side. H again stands for the hours. P is the total cost for the plumber. By the way, you'll notice that I'm pretty careful about labeling things. Part of math is learning to communicate what you're doing to other people. So take that extra just moment or two to label things, and it not only helps you as you go on, but it also helps your reader, who in this case is your teacher, and that definitely helps your grade as well. All right, in terms of hours, he can't work less than 0 hours, right? Wouldn't make sense to have a negative number, so I'm going to start with 0. And if you're thinking, well, could he really work 0 hours? Technically speaking, if he comes out to your house and, maybe you forgot he was coming and you weren't there, he's still going to charge you the service call, right? Even though he worked 0 hours. So we're going to include 0 in our table. If we plug 0 in for H in our function, 80 times 0 plus 25 is just the $25 service call. Let's do a few more. What if he works for 1 hour? Well, if I plug 1 in for H, I'm going to get 80 times 1, or 80, plus 25 is 105. As the numbers get bigger that I'm plugging in, it gets a little harder to do the arithmetic by hand. So for right now, I'm just going to grab a calculator to do my arithmetic. If I want to plug in 2 hours for H, I'd have 80 times 2 plus 25, meaning a total cost of $185. And we'll do one more. Actually, maybe we'll do 2 more. One more in a row. 3 hours would be 80 times 3 plus 25, which is 265. Now I could keep going, but I do want to indicate in my table that there is sort of an upper limit on the hours that the plumber is willing to work, right? Plumber's going to work a maximum of 10 hours. So I'm going to kind of show in my table numerically that I'm going to stop when I get to 10 hours. And if I plug 10 in for H, that's going to come to $825. Now, as I look at this table, because it was easiest, I plugged in whole numbers for hours. But this really isn't a discrete function, right? It's really continuous because the plumber could work a fraction of an hour. They could work 2.5 hours or 5.1 hours or something like that. So for simplicity, I just indicated whole numbers of hours in my table, but it would be a continuous function. That's going to be important when I graph it in my next step. So in the next box down, it says draw a graph that represents the function and that we must provide a scale on our axes. So create my graph here. And again, labeling is really important. It tells your reader what you're really graphing. So my independent variable always goes on the horizontal axis, and that's H, the number of hours. My dependent or output variable always goes on the vertical axis, and that's P, which is really the cost of the plumber. I want to go at 0 to 10 on my input on my hours. So you'll notice that not only am I kind of putting the tick marks to show where my values are, but I'm also labeling at least some of the tick marks so that my reader again knows my scale. On the vertical axis, I have to get as big as 825, so I definitely don't want to label by ones. I think, in fact, I'm going to go by hundreds. So 1, 2, 3, 4, 500, 6, 7, 8, 9, 10, would be 1,000. That's enough space to represent my points. All right, let's start plotting them. I'm going to grab a different color just to make it show up a little bit better. 0, 25. Let's see, my first tick mark is 100. 25 would be approximately here. 1 is 105, just a little over 100. 2 is 185, slightly below 200. 3 is, I'm sorry, I plotted that one wrong. Let me fix that. Two is 185, a little below 200. But there. 3 is 265, between 2 and 300. But there. And so on and so on. And then my last point, when H is 10, P is 825, 6, 7, 800, a little more than 800. Would be about there. All right, although we'll talk a lot more about this in the next chapter, I can't say for sure that this is a straight line. It looks a lot like a straight line, so I'm going to kind of make the assumption it is. Again, we'll talk more specifically about that in the next chapter. And I'm going to show this as a continuous function by graphing all of the points between my first and last point. Not just individual points, but all the ones in between. So there's my graph. All right, the last part of this was to identify the domain and range. And it asks us to write both the inequality and the interval notations. So the domain, that's all the possible inputs. So in this case, all the possible H values, which I know go from 0 to 10. So I could write the inequality, 0 less than or equal to H, less than or equal to 10. Or I could write the interval notation from 0 to 10. And notice I used the brackets because the plumber could technically work either 0 or 10 hours. All right, what about the range? Range is all the possible outputs. So that's going to be all the possible values of P. And we know the smallest value here was 25, and the largest value was 825. So from 0 to 825. Right, there's the inequality notation. Boy, I'm sorry, I'm not too sharp this morning. We'll try that one more time. I didn't say 0, I said 25, right? If you work 0 hours, still charges that service call for $25. There we go. So from 25 to 825. And again, I could write that in interval notation using my brackets. All right, let's go ahead and I'm going to take a look now at how I might have done this on Desmos. And then we're going to also fill in our second column over here using Desmos to help us a bit. So keep your piece of paper handy, but pull up your Desmos screen. One of the really cool things about Desmos, which is already an advantage over a graphing calculator, is it understands function notation. So I'm going to go ahead and I'm actually going to put this function for the plumber right in here. I'm going to say that P of H is equal to 80H plus 25. Okay. Don't worry about the graph for right now. We're going to talk about that in a couple of minutes. Now, when we wanted to plug in values of H, we were doing so in the calculator. And in the calculator, I had to type in 80 times whatever number plus 25 each time. There are a couple of shortcuts that I could use on Desmos to do this. First of all, because it does understand function notation, I can just say, what is P of 2? And it'll give me that 185 right there. Or I could say, what is P of 10? And there's that 825. So already it's saving me some time because I don't have to type out the equation like I do into the calculator each time. But there's an even bigger time savings. Desmos will actually generate the entire table of values for me. In order to do that, I need to go to this little plus sign up here in the corner and tell it I want a table. Now the default for Desmos is always going to have this x1 and y1 here, but actually my input variable wasn't x, it was h. So instead of x1, I'm going to replace that with h1. By the way, the little subscript 1 just indicates that it's the first table that we've used. If I used additional tables with the same variable, I might use h2 and so on. But you do have to have that subscript for Desmos to understand. So I'm going to type h1 as my input. And then for the output, I really want Desmos to take whatever value I put in the h1 column and plug it in to my function. So what I actually want is p of h1. Now look what happens. When I plug in 0 for h1, it automatically substitutes it into my function and gives me the output, the p-value. I can do that, and once it sees that I kind of have established a pattern that I'm going up by ones each time, I don't even have to type the 3 and the 4 and the 5. I can just keep hitting enter, and it will continue to give me the outputs. Of course, if I wanted to skip around and not go in order, I could always type in a specific h value. So there's a way of very quickly taking an analytic, or function described with a formula, and converting it into a numerical table of values. The next thing that we did was we put in the, or we wanted to show a graph, right? We've got the analytic, we've got the numeric. We now wanted a graphical representation of the same function. You can see over here, Desmos is kind of doing that automatically for me. It's already drawing the graph of my function. But there's a couple things I'm not crazy about. First of all, obviously it's not showing the window, the domain and range that I really want. So I'm going to fix that first. The easiest way to do that is to go ahead and actually I think I'm going to fix the vertical axis first. Just get your mouse, your cursor near the vertical axis and push down the shift key. Notice how it kind of turns it blue? When it does that, I can just use my mouse and I can drag. And when I drag, it changes the scale on my vertical axis. So I'm going to do this and I'm going to actually come way down because I want to see some pretty large values on my vertical axis, right? Remember, 0 to 1,000 is what we did when we did it by hand. Next, there's a whole bunch of stuff on this graph I don't need. I don't need any of the quadrants with negative values. So if I just click on the graph and pull it, I can actually move it so I'm not seeing a bunch of extra stuff that I don't really care about. And now that I've done that, I've probably got more than I really need. So maybe I'll come down here to the x-axis and say, I only really need to go up to about 10. And back here to the y-axis and say I don't really need so much anymore. I only need to go up to about 1,000. All right, so that's an easy way to adjust your axes. Hold down the shift key and then just use your mouse to drag. There is another way. Over here, the little wrench in the upper right-hand corner, if you click on that, you actually can do a lot to your graph. You can turn your grid on and off. You can take away the axis numbers or put them back. You can make fewer grid lines or more grid lines, right? Lots of things you can do here. And you can set a specific window for both the x and y axis if you want to, although I will say I find the click and drag method a little easier. I am going to do one thing here. I'm going to add a label. Our horizontal axis was h, the hours. I'm going to put that label in. And I'm also going to label the vertical axis. This was p, the cost. You'll notice now when I just click back on my graph, my axes are labeled H and P, just like I might have done by hand. All right, so that's a quick introduction to a bunch of really cool things that Desmos does. Oh, one other thing. If I want to, I can change the color here. Over in this little graph symbol, if I hold that down and select a different color, I can change the color of my graph. And I can do the same thing over here with the points. If I hold that down, I can change the color there as well. All right, let's go back to the electrician. This time I'm going to do everything in Desmos rather than doing it by hand. So we now want to make a table of values that illustrates the function for the electrician. So I'm going to start by putting in my electrician equation, E of H, and that was 65H plus 40. Now you kind of see why it's nice to be able to control the color. The electrician graph over here is already there and it's in blue. It makes it easy for me to tell which graph is which. All right, so if I want a table of values, I have a couple of options. One is I certainly could create a whole new table of values. But if I come up here where I've already got my table of values for P, I can click over here in the third column and I can add E of H1. And then I don't even need to retype my hours. It's just going to go ahead and give me the values for the electrician for E. Let's see, that was a blue graph. I'm going to go ahead and be consistent and I'm going to change the color of the points on it to blue as well. So there's a numerical representation for E. And if you're following along on your paper, you might want to take just a moment and make that table on your paper. I'm going to do the same, so I'll give you a moment. All right. You can also see the graph here. It's done very nicely with Desmos, but I'm going to go ahead and translate what I'm seeing. And notice these really did turn out to be nice straight lines. I'm going to go ahead and translate that rather, onto my paper. So I'm going to flip back over to the paper. I just kind of copied over my table here, and now I'm going to draw it. So again, H is for hours, and this time I've got E for the cost of the electrician. The electrician, remember, only worked, you know what, I actually made a mistake up here. Let's go back and fix it. I just realized there was a piece in the instructions that said the electrician won't work any more than 8 hours. So actually, I should have stopped this a little earlier. No more than 8 hours for the electrician. And in Desmos, let's see, what was that? 8 hours was going to cost $560. So $560 is actually the most I would be paying the electrician for the day. All right, let's get that onto the graph. So my hours, 0 to 8. And let's see, the most I'll be paying him is $560, so 100, 2, 3, 4, 500, 6, 7, 8, and so on. All right, 0 hours, just the service call, $40. 1 hour is $105, a little more than 100. 2 hours is $170, bit less than 200. 3 hours is 235, maybe about here. And then the most is the 8 hours, 6, 7, 8. And that's going to be 560. Between 5 and 6, maybe about there. And then I will connect those points. Because again, it is a continuous function. He can work fractions and decimals of an hour. All right, and there is one way that my hand-drawn graphs are slightly more accurate than the ones on Desmos in that I controlled my domain and range. Right? So speaking of domain and range, let's finish out this page by jotting down the domain and range for this function. So the electrician works between 0 and 8 hours. Oops, hours. In interval notation, I can use the brackets from 0 to 8. And the range, the output, would be the E values, the costs. He makes at least $40 for the service call and no more than 560 for his 8 hours. Or an interval notation from 40 to 560. All right. We're now going to answer a few questions. And again, I'm going to try to show you how we can do this using either a by hand method or a technology method. The next question is find E of 2 and explain what it means. Now, of course, if I'm working by hand, I can actually plug 2 in to my function, although we've already done that. We've got it in the table here. So E of 2 equals 170. I could have also seen that on Desmos, either by looking at the table, E of 2 is 170, or again, because Desmos understands function notation, I can actually ask it for E of 2 directly. All right, explain what it means in terms of the situation. Again, here I'm looking for a nice full sentence, something that somebody could understand even if they hadn't seen anything else in this problem. So I might say, if the electrician works for 2 hours, the cost will be $170. And notice that's a sentence you could read and it would make sense to you, even if you'd not seen anything else in this problem. You'd understand what your bill was, right? All right, next, find H so that P of H equals 305. All right, well, my P of H equation was 80H plus 25. And I'm going to take the 305 and plug it in place of the whole P of H, the left-hand side. So by hand, it looks like this. 305 equals 80H plus 25. Now this is an equation that we can just solve, right? We can subtract 25 from both sides. So that would be 280 equals 80H. And then divide both sides by the 80 to get the H by itself. And that's not going to come out quite evenly, so this is going to be a portion of an hour. Oops. Sorry, my calculator still thinks it's graphing. There we go. 280 divided by 80. Is 3.5. So, what does that mean? I found the H value, but what does it mean in terms of the situation? Well, the hours are 3.5, and we're talking about the plumber. So if the plumber works 3.5 hours, the cost is going to be P of H, that's the 305. And notice again, that sentence makes sense whether you knew anything about the rest of this problem or not. Now, could I have done this with technology? Well, the answer is yeah, actually I could. Let's go back over here. I can't do it really directly from the table because if you'll notice, 305 is not on my list because I didn't choose any fraction or decimal values for H. So instead, I'm going to do something else that's going to help me to figure out where P of H equals 305. First of all, I'm really kind of only interested in the plumber right now. So let's turn off all of the information about the electrician. Notice I just clicked right next to those little circles. I can put them back by clicking again. But for right now, I'm only interested in the plumber information, the P function. I could try to sort of estimate by kind of just clicking on the graph, 296, 301. It's hard to get exactly 305 by clicking, so that's not a really efficient method. Instead, what I'm going to do is I'm going to add an extra line to my graph. I'm going to add the line y equals 305. And notice what that just did. It put this line at a height of 305 all the way across there. And then Desmos automatically knows, hey, oftentimes they're interested in where one line crosses another, the intersection point. So it kind of marks it for me, and now all I have to do is click on it. And I can see, yep, I do get an output of 305 when H is 3.5. So that's a nice little trick you can use when you know the output variable. Go ahead and just graph y equals whatever that value is, and that will give you an easy way to find the input variable value that you need. Once you're done, you can either totally get rid of this, or I could have turned it off if I thought I was going to use it again. All right, let's go to the next problem. I want to find E plus P of 6. Now I'm going to say that's E of 6 plus P of 6. And again, I certainly could plug the 6 in for H in both the E and the P, but I have that value already. In fact, this time I think I'm going to use my table. E of 6 is 505. Excuse me, P of 6 is 505, and E of 6 is 430. So I'm going to transfer those values to my paper. E of 6, 430, plus P of 6, 505. And then I can just add them up, 935. And let's see, what does that mean? Well, this time it looks like we have both the electrician and the plumber working for 6 hours. And our cost for that is going to be $935. So the cost for 6 hours with both the plumber and electrician is $935. All right, could we already kind of used technology for this one by using the table, but I'll also mention again, Desmos does understand function notation. So had I chosen to, I could have just typed it in as E of 6 plus P of 6 and gotten the 935 that way as well. All right, I think we have one more question about the plumber and electrician deal here. Find the E intercept and explain what it means in terms of the situation. So this is where the graph crosses the E axis. All right, I'm going to do this one first with technology, and then I want to talk about how you could have done it by hand. So coming back over here, right now I've got the plumber's line on. I want to go back and put the electrician's line on. So I'm going to turn off the plumber's line, and I'm going to turn on the electrician's line. Okay. Now actually I've got this labeled P for the plumber, but we actually know it's electrician now, so let me switch that over. There we go. And the graph crosses that E axis right here. Again, so much in Desmos is just click on it. And the point 040 is my E intercept. How could I have gotten that by hand? Well, remember last time we talked about the fact that to get an intercept, you just substitute 0 for the opposite variable. So if I wanted to do this by hand, I could say I get my E intercept by plugging in H equals 0. So I could have done E of 0, which would be 65 times 0 plus 40, and I could have gotten the 40 that way as well. All right, what does it mean? Well, the hours are 0. So if the electrician works 0 hours, the cost is $40. Again, that's just the service charge. That's that situation where you made the appointment, he comes out to your house, but you forgot and you left, and he's still going to charge you for the trip to the house.